So the recording shall have just initiated. Thanks again, everybody, for attending. This is Easy CNC with ShopTurn Setup and Programming. This content will be specific to the 828 and 840 controls, going through operation of the system, jogging, setting some tools and offsets. We'll look at some of the content as we go through, as well as part programming. My name is Chris Pollock, for those of you that may not be familiar with me. I am the dealer support specialist for the East Coast for Siemens, and I will be presenting today's content for you. My information is up there on the screen. Certainly, if you don't have a chance to write it down now and you don't have it, again, these recordings will be posted for further viewing, so you can always come back to it and get my information if you'd like to reach out to me with further questions. So these live seminars, they're new for us. We've been trying to get them out once a month over the last few months. We've had a few that have already gone through, and we have a bunch more coming up in the future. So today we're certainly doing the ShopTurn setup and programming content. Next month's going to be a little tight with the IMTS shows, so I probably won't have an opportunity to post the next one till October. But the next one will be shop mill, so it'll be very similar layout of content, but it'll be specific to shop mill for the 828 and 840. After that, we do a commonality between shop mill, program guide, CAD, CAM, and ISO mode. So that'll kind of show you how all the different modes of the control kind of work together and how you can move between them depending on how you create your part programs, whether they're coming out of a CAM system, you're writing a G-code at the control, or using shop mill. So that'll be another one, and then we'll have many more coming up in the future. The content will be specific to any of the three primary controls in our market: the 840, the 828, and the 808 control. As well, I did say earlier, but all of these recordings are posted on our CNC for You website as well, so you can access that if you would like to. So today, again, we're specifically looking at the 828 and the 840 platforms. Overview today, we're going to take a look at CNC ShopTurn and apply it to a 2-axis turning machine. So we'll go in, we'll talk about setup a little bit, talk about how to set some basic part zeros, move the machine around, maybe create some tools. We're certainly going to go in and create a part program and even go as far as run it in the machine. So you should get a pretty good understanding from start to finish of what it would take to set up a job, create a basic program, and even run it in the system. This is the example we're going to use when we get to our programming example. So a simple turning example, we're going to face off our part. We're going to create a contour as you see. We'll put a nice little relief. We're going to come then in and machine a thread on the part. We'll machine a 1'8" thread on this part. Once we've done that, we're going to drill a hole through the center of the part, so you get a chance to see how the drilling cycles work. And then we're going to part the part off using our part off cycle. So when we're all said and done, we should have a complete part. I will keep bouncing back to a PDF that I have just to refer you back to the dimensional data as we start to put different features in. This webinar is probably going to take anywhere from an hour to an hour and a half. I didn't want to cut it short, so we'll get right into it right now. So the first section we're going to look at is going to be jog mode. So in jog mode, we're first going to take a look at the jog screen or the manual screen. So this would be my main screen where I can start to move the machine around. We can do tool changes. We can set some basic offsets. So we'll come through. We'll talk about the TSM screen. Then we're going to go and look at how to set a tool 0 and a part 0 through the measure workpiece or the measure tool function. We'll take a look at the offset table a little bit, where I create a tool, and we could even maybe create a tool as we're writing the program. I do have a bunch of tools pre-created for us as well. So with that being said, what we're going to do is we're going to switch over to our SINUTrain software. And SINUTrain is basically a machine tool emulator. So it is the identical software you would see running physically on your control. It gives you all of the same functionality. So I can move the machines around. I can set zeros. I can even go into auto mode and run a part program. So it gives us a very good representation of what the machine tool would do in an offline piece of software. And this software is absolutely available in the marketplace. So if you'd like to purchase it, it is very available for you. So the first screen or first function we were going to talk about is the TSM field. So first, before we go any further, where am I at in the control? What am I looking at? Well, right now we're in the jog screen. I know I'm in the jog screen because if I look in the upper left-hand corner, I see I'm in my machine mode, and my jog screen light is up. Typically, this is usually the first screen you see whenever you power up the machine tool. Possibly, if your machine requires referencing, you may see the reference point screen first. You initiate a cycle start or go through whatever the manufacturer's specific homing process would be. And then if that's the case, the next screen you would see would be jog. Generally, it's one of those first screens you always see when you power up the machine. So the jog screen was created to allow you to start moving around the machine, setting offsets. Now, we created the functionality of this screen to be very aware of keeping things simple for operators, not bombarding them with a lot of heavy, cumbersome commands and instructions. So you'll notice as we go through it, there's a lot of visually graphical screens that kind of guide you through the process of setup and moving the machine around. We keep you from having to go to maybe like MDI screens and put in a lot of G-code and M-code functionality just to keep things simple. So with that being said, the first screen we're going to take a look at is our TSM screen. And that is the button in the lower left-hand corner of my display. And what TSM allows me to do is TSM allows me to do tool changes, spindle commands, other M codes. So if I want to fire up my coolant or something along those lines, a mister or whatever I happen to have attached to the machine, I can load different work offsets. I can even change my unit of measure. So all this stuff is very typical functionality that you would normally do through an MDI screen in a control. But by creating this simple little interface screen, it keeps the users from having to know and learn all these heavy-handed commands. So if I want to do something as simple as just physically change my tool, if I look at the TSF window, the TSF window is just a quick representation of what's active at this point in the control. So it knows that I have some plunge cutter physically loaded, maybe some feeds or some spindle speed states. So if I simply come down and I can move my highlight around with my blue arrow to my tool field, I can now hit the select tool key in the upper right-hand corner and get access to my tool table. So my tool table is showing me all of the different tools that are physically loaded in the machine currently. So let's say we wanted to spin to turret position number 1 and get to our CNMG 432 or our 80-degree OD roughing tool. Well, I can simply highlight that tool by moving up with the blue arrow keys, select OK. Machine fills out the name of my tool, and now it's just waiting for simple cycle start. By pressing cycle start, we'll initiate a tool change automatically for you. So the machine now would do anything the builder prompted or wanted it to do for tool change. If it has to go to a retract location, it would go to that retract location. If they're just allowing the turret to spin at that point, it would do that. But you'll notice in the TFS screen, I now see my new tool loaded in my turret, so it's spun to that position. Would have loaded any offsets that may be set for that tool, and I can now continue moving on with that tool. I'll use this for maybe turning my spindle on. So let's say, for argument's sake, I wanted to start up my main spindle at 500 RPM, and I want to give it a direction. I'm going to use my select key to define some kind of a direction. So maybe I want to move clockwise. And now I'm going to simply hit the cycle start key, and you'll see my spindle will turn on. My feedback will even show me that the spindle is now spinning. Everything's running. So these are the typical steps I would use to spin the turret to some location, fire up my spindle, and get ready for maybe setting a tool, setting an offset. As well, if I wanted to load up a work coordinate, I could come in, select a specific work coordinate that I want to use, that I want to activate for setting zeros, cycle start, and that would initiate loading of that work coordinate. Anything within the TSM screen will require a physical cycle start to then activate. I can also use this to maybe turn my spindle back off if I wanted to by using the X with the circle through it. Cycle starting that command, spindle shuts off. So you'll use the TSM screen to do a lot of your standard manual functions. From there, let's say I wanted to jog the machine around. So I can jog utilizing my axes right here. So I pick a given axis, I can select the plus or minus key, I can start to move the machine around. Maybe I want to move Z, so I select Z. You'll notice this has a Y-axis plus other axes. Certainly this machine could support many axes. This one's just commissioned for a couple. This was built to support C-axis capability in live tooling. We won't be going through that today, but we could in the future, absolutely. So with that being said, maybe I want to come in and set a tool offset. It's a very common occurrence that you'll find yourself doing when setting up a job for a lathe. Well, certainly the first step would be load the actual tool that I want to set. Potentially turn my spindle on to some direction because I'm going to come in and take a little light cut or whatnot. And then what I'm going to do is I'm going to use this measure tool function. So measure tool allows us to come in and set our tool offsets. So once I select the measure tool button, and it's selected by going blue, I just clicked on that button, I can now pick in the upper vertical soft keys, our upper right-hand corner, the manual or the automatic buttons. So manual would be, I'm going to physically come in and manually set this tool, probably take a light cut on a piece of material. Automatic would be if I had a presetter, let's say, on the machine. So we're going to go through just manually setting a tool today. I select the manual function. You'll see that the tool is already pre-selected. It knows what's in the turret or what's loaded, so it automatically defines that. I would then probably, jog the machine or hand wheel the machine to some location, come in, take a light cut. We would go down, measure up our part, maybe mic up that diameter, and then I would tell the system in the X0 field, what is the diameter I'm physically sitting at? So, you usually take a cut, move her straight back in Z, leaving the X still aligned with that edge, shut the spindle off, measure it. Maybe we found that we were at 2.5 inches. I simply type the diametric value, 2.5. The system will automatically cut that in half for you. And then I merely type it in and then press the set length function. So before I hit it, I want you to take a look at our work field. The work field is displaying our absolute positions relative to some offsets, some zeros. So you see how it's sitting at 23.68 right now. We hit set length, and all of a sudden it applies to 2.5. In our control, whenever you set any offsets, we will immediately load those offsets. Same scenario if I was to adjust the offset, maybe by applying a wear. So we were running this tool, we wanted to maybe go to the offset table, go to my wear field, and tell it that I'm, maybe I was a little big, so I want to reduce the offset by 5 thou. Well, if I come back out, you notice I didn't physically do anything with the tool or move the machine, but immediately it's reflecting that offset. So whenever you're setting any offsets, you always want to verify, as long as that's the tool that's called up, or the work corner that's called up, that the display physically changed. If it didn't, you need to stop and kind of go back and figure out maybe what you did wrong as to why that tool didn't properly update or that offset didn't update. So in this case, Z, maybe I came over, took a light cut in the face of the part. I could tell it 0, I could tell it some small positive or negative distance depending on where I'm setting it, but I did the same process. I give it a value, I hit set length, my offsets change. Now, you're going to do a lot with measure tool because you have a lot of tools to set up very typically in a lathe. So here, I can stay within this screen. So let's say I was to move back, move out a little bit, and now I want to change to some other tool. Well, if you arrow back up to the T field in the measure tool field, we can initiate tool changes just like the TSM screen you just saw. So here, I hit select tool. We can maybe arrow down to our finish cutter, say OK. That tool name is now loaded. We'll talk about tool names in a little bit when we create some tools. But the tool is physically loaded. Now I just have to execute it by hitting a cycle start. You see now, it loads the new tools. My offsets change because I don't have any offsets yet for this. Now I would repeat the same process. I would, potentially jog down, jog over some location, maybe move Z, and then give the machine, tell it whatever axis I'm setting. It will retain the value, so if I'm just going to touch a lot off to a predefined axis value, I don't have to keep typing them each time. Then I just say set length for each of them, and I've just established the offsets, and you'll just follow that process. The graphics will update depending on the tool that you've selected. So, if you go to drills and end mills, you'll see it'll update to reflect that and try to give you a little better process of what we'd be expecting you would do to set this tool. Generally, there's a lot of different ways to set up lathes. Generally, a lot of guys like to set up all their tool offsets either to a fixed datum or to maybe just the part. And then they'll adjust all of the tools by applying some value in a work coordinate. So in our machine, you can do that by simply going in. I'm just going to put that turning tool we had in before back in. By simply going to my Measure Workpiece field. Measure Workpiece allows me to move over to some location. So maybe I was to move to some position. Now this is, let's say, where I wanted to set a work coordinate value. So what the work coordinate value would do, it'll move all the tools the same amount. So if I had pre-established maybe all of my tools to the face of my chuck, let's say, and I wanted to now move over just one given tool, touch the front of my new part, and then have all the tools set there. This would be a good example of where I would use my Measure Workpiece field. I would move the machine back, touch the physical part, select whichever work coordinate I want to use, tell it what I want this value to be. So maybe I'm hitting a 1, 2, 3 block or a piece of paper or shim stock. I could tell it maybe a small value. From there, hit set work coordinate. You see how my display changes. Now that value didn't change for the tool offset. It actually applied to the work coordinate. So we'll go into look at the offset table here in a second, and you'll see where some of these values wrote. As well, other common things you could do within the jog screen would be maybe position the machine around. So here I can tell it to, feed to some location. Maybe I want it to go to an X of 2 inches. Cycle start. The machine would run and do that as commanded feed move. You can do rapid moves here. So you can just kind of move the machine around in its work envelope this way. We give you a basic stock removal screen. This is the simple can cycle that allows you to do a basic simple stock removal. So if you wanted to turn some soft jaws, let's say, and maybe I'm going to work on an ID set of soft jaws, I wouldn't have to write a whole program. I could fill out this one little event. Once I fill it out and I have good numbers here, then you will get the accept key. And once it's happy, this becomes a little program. So I could legitimately hit cycle start, and this program should run. I didn't give it any valid numbers, but it's just a quick, simple way for me to do some basic cut paths. And depending on the machine tool you purchased and how the builder has configured it, we may bring up a lot of these different can cycles up on this screen. A lot of our teach lathes, engine lathes that have the ability of running kind of manual and CNC like a hybrid machine, they'll give you a whole bunch of different can cycles up in this mode, and they all work kind of the same way. Now, what we want to look at here as well, we were kind of moving the machine around and jogging around, setting a couple offsets. I do want to show you the offset screen briefly. So in the offset screen, I'm going to get there by hitting the hard offset button. I will see our tool table. And the tool table is a physical tool list. The tool list is going to contain the tool, the offsets, and some of the geometry that makes up the given tool. Tool wear is just how I can adjust small incremental values of wear. I also have my tool life management here. Magazine is more reserved for machines with, like milling machines with random tool changers and carousels and whatnot. But you do have the ability of that functionality here as well if it's a more complex machine. And then offsets is where all of my work coordinate or work offsets are set up. So if I come in and I look at my G54, I can see where that number got inserted when I did that work coordinate offset set. So just like when I set my couple tools, now these values are a distance from some machine location potentially to wherever I was setting the tool. If I was basing everything off of a gauge tool off a work coordinate, then these could potentially be just small incremental values from some datum to that tip. So with that being said, let's say I wanted to create a tool from scratch. Why don't we build one at least so you can see the mechanism? Certainly we don't have enough time to build all of the tools for the whole part program, but if we can build one or two, it'll give you a pretty good understanding of at least the start of the mechanism. So the way tools work in the Siemens world is you're going to potentially have tools sitting in a physical location. This would be a position or that is physically loaded in the machine, or they can be in what we call an unloaded state. So we allow you to build or move tools from inside of the machine tool to outside locations just by being in a loaded state, meaning they have a location to the left and they're physically in the machine, or what we call an unloaded state, meaning that they still exist, but they don't exist in the machine. Some builders force you to make tools that are automatically in an unloaded state and then go through a loading process. Other builders do not. It's really kind of up to the builder how he wants to set up the machine. So in this case, let's say I'm going to build a tool in an unloaded state. I could select New Tool, and now I see a full tool library of different tools we support. We're initially just looking at what we call our favorites screen. So this is some very common tools you might want to use. Then you can go into more detailed tools, showing you all different kinds of cutters, and right angle heads, and all sorts of different die mold end mills and ball end mills, drills, all sorts of different drills and taps we support, all kinds of different turning tools. We do special probes and star probes and stops. There's a whole large list of tool libraries that are here for you. Normally, most of the stuff you're going to use is going to be found under the favorites screen. So let's say, for argument's sake, we were going to come in and create a standard turning tool. So maybe it's going to be a roughing tool, so I'm going to leave the roughing tool highlighted. And then I have these orientations. Now, it may be hard to see on your end, but if you look close, you'll notice that the first one has a little orange tinge to it, orange in relation to the other tools. Well, I can move that orange highlight around to each of these tools by using my arrow keys. So this is how I define the orientation of the tool, how it sits in the physical machine. This machine is set up as it was a slant bed. So this has a rear turret. So this first tool would represent an OD tool. If this machine was a front turret machine, then you would see everything would get flipped backwards. Our icons, our placement will always represent or match the way the machine was built. So the first position always represents an OD tool, but you might see the icon would look like this third one over here. So what you'll do is you'll kind of scroll through, and you have a whole bunch of them. If I'm going to do neutral tools, I can get all my different orientations for my neutral tools. So we have, in this case, 8 different orientations I can pick from. So in this one, I'm going to pick my first orientation, and I'm going to say OK. Now, I happen to have the naming automatically turned on, so it gave me a rough name. And this is probably one of the first things that guys notice that's a major difference from us to a lot of our competitors, is the fact that tools do not have to be numbers in our world. They can be. There's nothing wrong with being a number, but you can call it anything you want. I like it because I can build in kind of user comments or notes right into the name of the tool. So let's say, for argument's sake, I wanted to build a 35-degree tool. I could tell it it's put my caps on, a VNMG, and maybe it was a 332, insert IC in radius, and I happen to know that that is an OD tool. So this would be a normal way for me to put in some different information I have right in the name of the tool. Chip breaker. You get pretty elaborate. We support quite a few characters within a given name. You type in the name, whatever you want. Letters, numbers, we support anything you want there. Even you see forward slashes in some of mine. We can do special characters. You hit enter, and then it moves the highlight over to the X length. Enter on the control would also be the yellow input button right here. The length for X and the length for Z will get filled out when you do the set length functionality. So you don't have to put any numbers in there unless you happen to know them. If you're presetting tools or have known datums, you can type them in directly. The next thing would be my radius. I have a number 2 rad, so that would be an 031 radius, so I'm going to type it. My primary cutting direction. Now the system figured that out based on the orientation I chose, but if I wanted to flip things around, I could change my primary cutting direction. Certainly the 2 primaries for this tool would either be down or to the left. You'll notice if I put the wrong cutting direction, we put a little indicator here on the insert to say, hey, things aren't quite jiving. So in this case, I'm telling it to have a left-handed tool, but cut to the right, which doesn't like that very much. So we'll do a standard left-hand tool, cutter direction. The next field is our relief angle. And that is basically my clearance. If you look at this insert picture to the top of the screen, it's the angular distance. So it's always added from 90 degrees. So if I have a 5-degree relief, I'm going to put 95. If I have a 3-degree relief, I'll put 93. 7 is 97. So you're just going to take 90 degrees and then add whatever that relief angle is to it. We have the physical insert angle. I know this to be a 35 degrees instead of being MG. And then I have the IC of the insert, so we'll say it's a 1/2-inch IC. And the IC is that inscribed circle in the insert, right? So that's how we can kind of understand how big the insert is. From there, there's a couple extra fields. You have your standard cut direction for this tool. So if I was inverting the tool or something like that, I could flip it over. And then I have my physical coolants. And you may or may not see multiple coolants. It really kind of depends on if the machine was built with a couple different coolants. So a lot of times I'll just see one. That'll be a standard flood. Then maybe the second's a high pressure or wash down or something along those lines. So once that's all filled out, I'm all set. My tool is created and defined. I have all the information I need to know about it. Now in this case, the tool is unloaded. So we know it exists, but it's not physically in the machine. So let's say it's time to mount the tool in the machine. I want to put it in the machine. I'm simply going to make sure this tool is highlighted anywhere on this field. It doesn't matter. And then I'm going to use the load button on my vertical soft keys. Load allows me to say, hey, I'm going to put this in the machine right now. And where do I want to put it? So maybe I knew that I want to put it in pocket 16. I type it in, say OK. Tool gets physically moved up. Do I now have to actually mount a tool in the turret? Absolutely. This is just a mechanism for us to manage the tools. But what's nice is, if you guys are dealing with a lot of tools and you're breaking down setups all the time, I can come in and say, hey, I'm not using the 3/8 MO right now, but the tool is still a valid tool. I'm potentially going to put it back in the machine at some point. So I can just highlight the tool, select unload, and you'll see I didn't delete the tool. I didn't lose its data. It's just sitting in an unloaded state. How many tools can I support in this screen? It's really up to the builder. It is builder selectable, but most of the time I see most builders will support 99 tools. So it's however many locations we have here, and then the rest of it until it equals 99. But we can support thousands of tools, so it's really, really up to a function of the builder. Now, the other thing I do want to point out when taking a look at tools in our system is what we call multiple cutting edges. So in the Siemens world, you can actually create up to 9 unique offsets for any given tool. Typically, when using this type of functionality in maybe some competitive controls, you would have had to sacrifice another offset number to use to be able to do this type of functionality. So, maybe I had 99 offsets. I would have to say, okay, well, I'll use offset 20 to match with tool 1 when I want to have a dummy offset or have a different offset. In our world, you simply select the edges function. And edges will allow you to create a whole new offset. So all I do is I select new cutting edge. And now you see how I get a second one. Now there's no number. This doesn't mean it's unloaded. This just means that these two are associated. In the Siemens world, when you're dealing with multiple cutting edges, you will then get a new number under your D field. And this is how it gets called up in the part program. It's a D number from D1 through D9. So you'll never see a D number larger than 9, because that's the maximum number of offsets we support. And then from there, it'll show us match this number. So this can be a completely unique tool. Doesn't even have to be the same physical tool. If I had a little gang tool set up here, and I knew that that I had a turning tool, a threading tool, and a part-up tool all on a little gang setup, I could do that right now. I could come in and say, okay, well, my second cutting edge is going to be going to be a threading tool, or my second cutting edge is going to be a part-off tool. Now, the one thing it doesn't let me change is the name, because it's always linked to this turret position. So it's only one name, so you might want to call it universal or something like that. But now these offsets are completely unique. So there's no association. In this case now, the LOC width, instead of the angle, this is my insert width. So if this was a 100 thou wide grooving tool, I would just type 0.1 here. I would type 0.1 for my grooving tool width, and that would be some of the parameters you'd use for a grooving tool. Okay, so we're now going to jump back over to our PowerPoint for a second, and we're going to take a look at the next area we're going to explore in this seminar. So next thing we want to talk about is our program manager. So you can start to see some of the functions you can start to use to set up a job, kind of jog the machine around, maybe create some tools. The program manager is an area for you to manage the programs in the machine. You're going to get to the program manager area by selecting the program manager button. That's typically a hard key somewhere on your panel. All of the hard keys can also be accessed via soft keys by simply hitting the menu select key. So if you have some kind of a custom front panel or whatnot, which is very common in our controls, you may want to just find the menu select key. Once you hit menu select, you will see those soft keys come up. We'll look at that in a second when we get to the live portion of the demo. Within Program Manager, I'll get a list of directories and areas where I can start to save programs, so we'll take a look at that. I have the ability of creating directories, creating different types of programs, so you're going to get a chance to see how to physically start and initiate a ShopTurn program. We can save setup data, so all those fields or features you saw within the tool table can be saved as a physical file. So not only can you manage part programs specific to a job, but also the tool data that makes it up. And the tool data is all of the tools as well as all of the offsets, all of your work offsets as well can be saved. So we can take a peek at that. And then from there, once we've created a part program, we're going to go into this ShopTurn programming interface, and we're going to start to take a look at all of the different kind of elements that make up a ShopTurn program. So the first thing we'll see is the program header. That's always going to be that first initial screen we always see when we first start a program. And there's a bunch of basic parameters we'll fill out in there and explain to what they do. Then we're going to get to the event editor, and this is where we actually start to give the program some depth. This is where we start to tell the machine what it's going to do. So we're going to first come into the editor, and it'll basically be blank, and then we'll start picking different operations using our software buttons like drilling or turning to go to a defined location or operation. We'll get a chance to see some of the can cycles. In this job, we're going to use a basic turning cycle for facing, and then we're going to go into our contour editor to machine an irregular shape, where then once we've programmed up the part, we're going to get a chance to take a look at it in our 2D and 3D simulation modes, and we can start to look at cutter paths and different features on the part, maybe look at it in 3 dimensions, maybe cut it, to start to look at some of the internals, especially when you get to some intricate internal work. It's a nice way to be able to see what's going on inside of the part. And that gives us now an opportunity to go in and physically explore some of these features. So I'm going to select SINUTrain again. It's going to put us back over to the SINUTrain portion of this demo. From here, like I said, I'm going to use the Program Manager to get to Program Manager. This button will get me right there. But if you can't find the button for some reason, just simply find wherever the menu select key is. Menu select is always somewhere on a front hard panel. That's a must as far as all buttons. There's usually 2 you'll always see: menu select and machine. Menu select, and then I can see the different soft buttons for it. So Program Manager here, there's the software button for Program Manager. Sometimes we change our names on a physical function, but at the end of the day, as long as the icon matches. So if you look at the parameters button here, the second one over, and you look at the offset button, the hard button called offset, and you see that the same icon goes to the same place. We just happen to use a different name in the software button than we did on the hard button. That's all. Same thing with diagnostics or alarm. Same place. If I hit the alarm button, it's going to go to the alarm area. If I hit menu select, hit the diagnostics button, it goes to the same area, the alarm area. So again, you can hit Program Manager to get there, or you can hit menu select and then Program Manager. You come in, and this is the Program Manager. So this is where all of our programs reside in the control. What you're first seeing is the NC directory. So this is active internal NC memory in the machine. Within the NC memory, we've kind of set it up to feel very similar to like a Windows environment. So I may first come up and see my 3 core folders: part programs, subprograms, and work pieces. I can use my blue arrow to move my cursor up or down. I can use my right or my left arrow to expand or compress different folders if I want to look in them. So here is areas where I can start to find where my part programs reside. Now, programs in the part program folder can only have and must have an MPF extension. That stands for main program file. So you can't have any additional different types of programs here. This is just a simple folder for you to start creating part programs. If you want to start to create your own subprograms and group different part programs and have all kinds of different files and whatever at the machine, you can have PDFs, you can have the prints physically at the machine if you wanted to. All that needs to be done in the workpiece folder. So in workpiece, I have the ability of selecting new and creating a directory. So by selecting directory, I could say this is going to be my demo programs, whatever. Now, when creating folders, I can use letters, I can use numbers, the same thing with file names. But other than that, the only extra character we support in a name, especially in a file name, is an underscore. In fact, if you try to do a space or a minus sign or an asterisk, we'll tell you that we don't support that character. So when creating names, it's either a letter, a number, or an underscore. In this case, I'm creating a directory. So now you'll see it created this demo programs directory. If I expand it, there's nothing in it yet, but now I can start bringing programs in or out. A question that always comes up in this area is how do I move programs in or out? Well, you have a bunch of different ways to move programs around, or areas where the programs can be residing, shall I say. One simple way to move around. And that's places like our USB, maybe a CF card. Maybe I could have a mapped drive on a network, and that would show up like a button like my local drive button here. So wherever I want to go, I'm just going to select that device. So if it's a USB, I would plug a USB into the machine. The USB button would go black. I would hit it, and then it would show me potentially whatever's sitting on that USB. My local drive happens to be a mapped drive I have on the machine. So, in this case, maybe I wanted to come and, go and grab a specific file. Like I got some example. Here's some program. So you find whatever the file is that you want to bring over, and it's now simply as simple as using our cut, copy, paste commands on the vertical soft keys. So select copy, go over to wherever you want to place it. In this case, I'll place it in my demo parts, hit paste, the file's now in. As well, you can edit files sitting in remote spots. You can even run them from there. So if you wanted to, you could run a file right from the USB or from your local drive. We tend to discourage people from running on the USB because it's not the most robust or stable of connections inherently in a USB connection. It's got a couple little pressure pins, but it can absolutely be done. As far as we're concerned, you could treat it as an external drive if you wanted to. If I wanted to get rid of a program, I can expand my vertical soft keys over by hitting the double arrow button, and then I can hit the delete key. And delete will warn me, of course, and then it'll delete that program from that directory, not from wherever the source was. I would have to go there if I wanted to. In this example, we are going to create a new part program. So I'm going to select new, and we're going to create a name. So ShopTurn, whatever I want to call it, I'll call this sample 1. Type in my name, select OK. I want to make sure ShopTurn is highlighted. And I'm in creating a part program. So the first step in the part program is to fill out the header page, and that's the page you're physically looking at right now. Question 1, what's the unit of measure? Am I using a work coordinate or not? Describe, you may or may not see. That's more common in machines supporting sub-spindles or live tools and whatnot. Gives us the ability of actually writing to the work coordinates from our part program. Generally, I'll just leave this at no, especially on a basic 2-axis machine. The blank allows us to describe what the stock looks like for simulation. Is it a cylinder? Is it a pipe? Is it some kind of square stock? Is it some kind of hex stock? So a lot of different support of different shapes of material. Then you define the dimensions. So in this case, I'm saying that my OD stock's 2 1/4. I'm going to leave a little bit of positive material. So I'm establishing myself all of my tools or the face of my part to be Z0. Anything negative into my part is going to be a negative number. Anything in front of my part or clear of my part is going to be a positive. So I'm just saying, hey, I want to leave 25 thou positive material to get cleaned up with my facing tool. What's the rough overall length of the blank? So this is always going to be greater than ZB, which is how far from the chuck jaws or the collet face is the part sticking out. And this is important because this is going to give me an indication if I get too close to my work holding and I potentially have a crash condition. Retract, how do I want to pull off the part? When you get into maybe more complex work like ID work or back turn work, you can toggle and have a bunch of different retracts. If I'm just doing a simple OD job, which basically in this case we are, I'm just going to give it a basic retract or a simple retract. The retract values can either be incremental or absolute. I personally like to use incremental if I can, except when I get into an ID boring application. Then sometimes it's nice to give it the the smallest diameter that bar could bore to. In this case, I'm just leaving 100 thou off of any surface that I can retract off of. Just be careful. If you set this to absolute, remember that's an absolute location. So this would then have to become a value greater than the part stock. And if I did less than, I could be getting errors or colliding into the part. From there, what is very unique to our control is the ability of defining the tool change location in the part program. So this tool change point is where the machine will physically go to tool change, and this is also unique to just turning in our world. The mills is different. So in this case, I can define 2 options. I can define a machine location, and I can use this teach position to say, hey, I just manually park the turret in some location. If I'm happy and I know it has full clearance to start spinning all my tools, I can just simply say teach position, and that will record wherever the machine is physically sitting right now. Or I can use positions relative to work coordinates and just throw some values relative to that. I don't have any real numbers in this machine, so I'm just going to throw in some simple offsets. But on the physical machine tool, a lot of times I like to use the machine button. It's a lot more permanent a location. It's very visual. Next, S1, that is a maximum RPM we're going to allow the spindle to run at while doing the part program, so maybe I don't want to go over 2,000 RPM. Safety, how close do I want to get to a part before I start feeding? So I'm going to let it come within 50 thou. And if I am doing milling, do I want to climb mill or conventional mill? And I default to the climb mill. If you don't have milling, you won't even see this option. So you fill out the page, you hit accept, and the event is there. I just saw a question came in. How do you access this view? I'm not sure which view he's speaking of. Pareto. If you have an opportunity, the one with the block, the block form I think you're talking about. So in the header, it's right here, the blank. I believe that's what you were talking about, the block. So that is just under the blank field. You can get to the block for the block form. Great. So this gives us a good opportunity to see how I can make editing changes. I had accepted it, and I had my event up on the screen. If you want to access that event to make changes to it, you simply hit the blue arrow to the right, gives the event back, come down to whatever field you want to change, hit accept, and it saves it. So the first step in this part program, just to show you guys real quick, to refresh your memory on the shape, we're going to face off the part, probably use an OD tool. If I take that same tool, come in and machine this OD, and then we'll come and do a turning cycle and a few different things. So my first step would be to face off the part. When you're programming, the highlight is always going to be just above wherever it's going to physically insert this command. So you always want to make sure you keep your highlight above. If you had moved the highlight down to maybe end of program, then you would have to move it back up because it would tell you that you're not allowed to insert after that point. So I keep my highlight at the top of my header. I go over to turning, and turning, you get an opportunity to see a bunch of different cycles we have for you in the control. Time allotting, I certainly don't have enough time to go into every one, but once you see one or two, they're pretty self-explanatory. So the first cycle we're going to use today is the stock removal cycle. So that's the cycle in the upper right-hand corner. And what stock removal allows me to do is it allows me to take some multiple cuts, whether it be on the face or the OD or the ID, for any of these atypical shapes. So a standard square part with no radiuses or chamfers, maybe a part that has some radiuses or chamfers in the corners, maybe a part that has some angles and radiuses and chamfers. I can define in the cycle if it's OD or if it's back turn, so you can get pretty elaborate with the shape. I'm going to use this for facing, so I'm just going to do a basic standard, no corner chamfers or anything. I'm going to first select my tool. So the first question the system asks is, well, what tool am I using? It is retaining the data from the last time the event was programmed. All of our fields are what we call user definable, meaning we don't decide what your defaults are going to be. They're just going to retain whatever state you last left them in. So in this case, I want to make sure I pick the appropriate tool, so I'm going to hit this tool select key, and that's going to bring up a quick reference of my tool table. If I see the tool here, great, I could just arrow up to that tool or pick it, in this case with my mouse. Or if I maybe didn't see the tool here, I may want to hit the tool list button one last time, and it'll put me all the way back to the tool table. Now, in this case, I do see a little indicator here. That's just because that was the tool that's staged at this point. So you highlight the tool just by moving the highlight to that point, and then you're going to press the to program button. What that'll do is that'll just fill out this field for you. Could I have typed the name out? Absolutely. But when you start adopting our naming terminology, it gets kind of cumbersome to start typing in all of these fields. So that's why we have this mechanism of just tool select, find the tool, say OK, fills it out for me. Okay, so I'm using my CNMG 80-degree diamond. Feed rate can be defined as feed per rev or inches per minute. I can toggle that. I'm going to keep it at feed per rev. I can toggle between RPM or constant surface feed just by toggling. I'm doing that with the select key. I can tell the machine if I'm roughing or finishing. So am I going to take multiple passes, or am I going to go right to these dimensions? Where is my shape? Is it OD? Is it ID? Just by hitting the select key and toggling through these couple of options. Is it in my face or am I turning? In this case, I want to face off, so I'm going to click face. And then you give it your basic dimensions. So I said my rough stock was 2 1/4, so I'm giving it my rough stock of 2 1/4. I said that I was leaving 25 thou of rough material on the front, so that's where my Z0 is. I'm starting 25 thou away from my part. I'm going to end, when I'm done, at center of the part. So this is X1 is my ending diameter, which is 0, because I want to face all the way to the center of the part. And when I'm done, I'm going to end at Z0 or Z1, which is an absolute position of 0. That's going to be the face of my part. And with the D, I can define how my depth per pass is. So in this case, I'm going to take 15 thou. So I'll take a 15 thou pass and then take whatever's left over at the end for a final pass. And then I could even leave a little material for a finish cut in the U field, UX or UZ. Whenever you see a U, that means finished stock. So you fill out a page, and as long as you did everything properly, you'll have the accept key. Now, if you put a funny value, let's say, like in this case, the feed rate's too large, what will happen is you'll lose the accept key, so you can't proceed to the next step, and we'll even tell you, right above the edit key, what we think is going on. So in this case, it's pretty straightforward. Feed's too large. Oh, I used a 1/2 inch per rev. That's quite a bit. I'll drop it down. I see the accept key, and I'm good. So usually, if you can get to this point, you're pretty close. Certainly, we don't necessarily know what, if your dimensions are correct, but the base structure of the cycle is correct. At this point, if I wanted to simulate, just to get an idea of what's going to happen, I can simply hit my simulation button, and I'll see this tool come down and just face off my part. So this gives you your first opportunity to see the graphics. Tool comes down. I have my show path turned on, so I see it come down and face off a couple pieces. I can toggle that on or off by hitting the double arrow key on my verticals and just hit show path or not. I'm going to back out. I want to continue on the program. I simply hit the edit button or simulation again. Either one will take me out. Puts me back to my editor. And now in this case, we're going to continue to move on. So if we look at the shape one more time, I can see that I faced up the part to size, and now I want to create this contour. So I'm going to go in and I'm going to actually draw this contour. Now, in this contour, I'm going to start right at the 1-inch diameter and put this little chamfer here. Then I'll feed back. I'll come down through this field. So you'll notice dimensionally on this detail, I don't know some absolute positions, but I roughly know how far in this relief's going and how far back, at least before my arc starts. And then I'll feed up and feed around. So I've got a few different things going on in this part. So what I want to do is I want to go to our contour turn functions, and I see that button right to the right of turning, to get to irregular shapes. So the turning handles all my standard stuff. Turning, grooving, all my simple shapes, square shapes, whatnot. But when I get to any irregular shapes, I'm going to use the contour turn function. Within this, I can do basic stock removal or basic turning for OD or ID. That's all set up right within this cycle. So you're going to get a chance to see this cycle here. But we also can do irregular grooving, or with the plunge turning cycle, we can do regular bidirectional turning. So if you take a look here, I'll come down to the help screen. So here the tool would feed in, feed over, feed down, feed over, and machine the part with like a groove turn kind of combination tool. But what we're going to do is we're going to do simple stock removal. Now when you get to these irregular shapes, first thing you always need to do is draw the shape. And that's why the first button in the upper right-hand corner is called New Contour. I select New Contour, and we type in the name of the contour. So I'm just going to call it something simple, OD. Once I've typed the name of the contour, I'm now just going to start to give it some elements or describe the shape. So these I'm getting right off the print. I said that I was starting, or I had a diameter of 1 inch and Z0. That's going to be where my thread starts. I do have a chamfer that leads up from the face, so I can tell this is a transition to the start of the element, and I can tell it the chamfer size. I select accept, and I now see the first point. This is sitting out at 1 inch. Now you're going to use these icons on the right side to kind of draw the shape. So I'm pulling back, so I'm going to say Z -1. On my part, I don't have anything happening when I get to the end of that, because I'm going to go into that relief. So I'm going to simply hit accept. Now I see my first chamfer, and I move back. Now it's drawing up top above this 0, because this again is a rear turret machine. If this was a front turret or front tool post machine, you would see this would be a mirror image of itself, and it would be drawing on the bottom side. So it's always going to represent kind of where the tool is. So when I want to do that relief, I'm now going to go into a 2-axis move by hitting the X button. And now we're going to give it some information. So if you look real quick on my relief detail, I see that I'm going to move in incrementally 90 thou and move over incrementally 200 thou. So that's the data that I'm going to give it. I'm going to come in and I'm going to toggle with the select key both of these fields to be incremental, and you can mix and match these. Both numbers don't have to be incremental. You can have one incremental, one absolute. But as I said, we're moving in 90 thou and we're moving over -0.2. It calculates out the angles for that location. I hit accept. There's my chamfer in. Now my next move, I'm going to do this as an arc. So I'm going to simply pick the arc event, define the direction of my arc, give it the radius. I happen to know the radius is an 8.125. Any of the fields will support math, so I could type in 8 and hit my input key or on my keyboard, my enter key, and it figures it out. I look at the endpoint on the print. Now, my print wasn't that clear, so I don't know where the endpoint of the arc is in X, but I do know in Z it's up against that wall. So that wall happened to have been at minus 1.375. I don't know the absolute center of the arc, but I do know that the arc is tangent to the previous element. So by simply hitting this tangent trans button, that's telling us, hey, this arc is tangent to that previous line. Now in this example, I see two different little dots, and I have this orange arc. And if I hit the dialog select button in the upper right-hand corner, I can get a small portion of the arc or a big portion. So when it mathematically calculated this, it said, well, based on the end point that he told me of 1 3/8, I could be going through that and hitting the intersecting the arc a second time with that line a second time, or I can be stopping the minute I hit that line. So in this case, I want to stop the minute I hit the line. So I'm going to pick the shorter of two. So my smaller segment is orange. And then just simply hit the dialog accept. If you pick the wrong feature, you can always go change selection, get right back to it, and select a different one. So I've came in, I selected those points. I'm now going to accept it. I have my arc. From here, we're going to just walk around the rest of the shape. So the part I happen to know moves out to a 1.750 diameter. Now, at the end of that move, it does have a radius, so I'm going to use the end of corner function until I'm going to blend a radius to whatever comes next. I won't see that radius here until I give it my next move, which my next move happens to be going back to 1'750". So now I see the radius come in, I move back to 1'750". Now we're going to do a 2-axis move. 2-axis move is going to go to a diameter of 2 1/4 in this case, and I'm just getting these numbers right off my print. -2. From there, I'm going to come back along the part. Now my part length ends at 2 1/4, but I am going to part it off. I'm going to want to go a little bit beyond it so I don't leave a ridge or a radius. So I'm going to say go to -2.3. I hit accept. Now there's a big question. Do I want to end at this point, or maybe I want to do a pull-off move? I can end at this point if I'm happy with this. But the only thing you want to understand, you have to be aware of, is the tool is going to come up and along the surface. Cutter comp is automatically enabled. I don't have to do any fancy things to turn it on. But since the system is going to see this to be the last move, it's going to automatically go beyond that point by the radius of the cutter. So in this case, 30 thou. As long as I know that's not going to potentially hit anything, I'm good. I'm clear. I can stop right now. If you want to make sure that the system isn't going to collide into my chuck jaws or anything that's coming beyond this, if you know that I can't let this cutter go any further past that, just do one final move off in the X, and that'll kind of gate this shape. So we're going to now hit accept, because the shape is now done. You see the contour is there. There's this little open-ended bracket that tells us that it needs a little more information. So now I'm going to decide which cycle I'm using. So in this case, I'm using my stock removal cycle. Come into stock removal. I'm going to flip this to roughing. I'm going to go get my tool. Do I have to give it my tool each time I come in here? No, tools are modal, so I could leave it blank if I want. I give it some speeds, give it some feeds, roughing or finishing. Am I on the outside? Am I on the inside? Am I cutting the face? Am I following a contour? I do a bunch of different stuff, turning or facing, outside or inside. Depth per pass. How much material do I want to leave for a finish cut? Now you'll notice I left this as a single diamond. That just means roughing. If I change it to a triple, it'll just finish. Or if I do a diamond plus a triple, it'll rough and finish with the same tool. I don't want to do that. I actually want to go back with a different tool and finish it, so I'm just going to rough it. So the material I leave here, the 10 thou and the 5 thou, will not be taken off until I come in with a finishing operation. DI is kind of a neat field. That's called an interrupted feed. So here I can give the system a linear distance, and once it comes that distance, it'll pause the servo enough to break the chip. So kind of like a peck drilling cycle. So let's say I tell it, 0.250. So it's moving in Z every 250. It's going to just stop the servo enough to break the chip and then continue cutting. Great with gummy materials. BL is what controls my blank, or what I'm really machining from. A lot of people think that I'm machining from the solid I set up in the header page. You're not. The solid in the header page is just simulation. This, right now, is what controls where the machine starts machining from. So a simple cylinder is saying, hey, look at the shape that I just drew, and I'm just going to assume, or I'm going to be machining a basic bar type of routine like you see in the graphic, and I can apply a little bit of additional material outside of the shape if I wanted to start machining away. So if I leave these two values at 0, 0, it's going to simply cut based on the shape that I drew. If I want to start further out, maybe all of a sudden my stock changed, I don't have to go change my headers or anything of that stuff. I'm just going to move this one number out. With that being said, however, I can also do allowances. So if you have a pre-machined part or a cast part, I can just tell it how much material there is based off the shape, and it'll just machine where it needs to. Or you can get it as elaborate as drawing a separate contour to represent the stock. And again, the machine will just machine where it needs to machine. So if I have contours or I have cast parts, I can do that by using the contour feature. In our case, we're going to do a simple cylinder. Relief cuts. Do I want the system to go in and try to turn that relief? Well, I'm going to let it try to turn that tool, and we're going to see what happens. So I'm going to say, yes, you can try to go into any reliefs. What feed rate do I want to come into it? And the final question in the cycle is, do I want to limit it? Limiting allows you to reduce the amount you're machining by creating kind of a box. So a good example of this is, let's say we had a large bar with a steady rest in the way, and I drew the whole shape, but I can only go really a foot back, not the 2 feet I drew. You could create a box, and it would not go anywhere further than the provisions of that box. We don't need to worry about it. We leave it at no. I select accept. Now, if we go simulate, you're going to start to see where we start to come in and cut with this part. Now, keep an eye on when we try to go into the relief on this operation. You'll notice that I get a small diagonal move in. You always have insert checking and gadget checking enabled. The system's never going to overcut what it can with that physical tool. So you'll get as much as you can, and now it's going to leave this material for you to figure some other way out. Certainly, if this wasn't a lot of material, I might just go into a finish cycle and let my finishing tool take it all out. Another option maybe would be to pick a different tool to rough with. Maybe I want to rough with a 55, not an 80 the whole time. Or if you have the option, and this is an option in our control, you can use a function called residual material. What residual material does is it gives me the ability of going and picking a different tool. So I'm going to pick my 55-degree tool, give it some feeds and speeds, just like you saw before, some cutting parameters like depth of cut, finish amounts. But once I hit accept, it's going to say, okay, I'm going to figure out everywhere that CNMG could not fit, and then go in and machine it with this DNMG. So you can see the system automatically figures out that my roughing tool couldn't fit here. So let me go in there with this finishing tool and just get that portion. So it really, if you do a lot of regular shapes, it allows you to quickly and proficiently handle areas where the cutters can't fit. As well with that, I'm going to want to go back to the turning cycle, go back to stock removal. In this case, I'm going to go to a finish because I want to come in and take that final finished material out. And since I left the tool blank, it's going to finish with my DNMG. So one final simulation on that, and you're going to see the shape. Now, I can go into 3D if I wanted to simulate it in full 3D. You can rotate and pan, do all kinds of crazy stuff. Zoom in. There's physical keys to do all of this. I'm just using my mouse because I'm cheating. But you have a lot of different controls as to how you're looking at a physical shape. I'm just using the side view right now. Okay, The next operation, looking at our part print, we've turned the whole thing. I want to put the thread on it. So we're going to put a thread on it. We're going to drill a hole, and then we're going to part it off. So as far as the thread, remember my highlight, I'm always inserting below, so I just leave the highlight on this last line I did. I'm going to jump over to turning, and then I'm going to go into the threading cycle by picking the threading button, the vertical. In threading, I'm going to pick a tool. I already created a tool. This was like a top-notch style Kennemental tool. I can define a table if I want to pick up a specific table, or I can just tell it that I'm going to define the thread as either a pitch, a modal command, millimeters, or threads per inch in inch mode. If you do that and your pitch is changing over the length of the thread, you can tell it that and it'll change. We also support tapered threads. Any of these cycles can support OD or ID, face threads, and even what's called chain threads, where the pitch can change and the shape of the thread can change over the course of the part. We're doing standard straight threading. So I define, in this case, I'm doing an 8 pitch. Now we have the fraction. If you're not using the fraction, you cancel the fraction out just by giving it like a simple 0/8, let's say. I tell it the RPM. Now one thing we can do that it's very unique in our system is you can thread in either RPM or constant surface speed. It is dependent on the builder whether they support this or not, but the control absolutely does support threading in constant surface speed. The other thing you can do in our controls is we do variable speed threading, where you can adjust your spindle speed live while you're cutting the thread. We do not cap the spindle speed. Feed rate obviously is a function of the pitch, so that doesn't matter where you leave it. It's always going to be 100 during the thread, but the spindle override is absolutely live. Some builders will not allow this functionality based on their performance of their machines, but as far as the control is concerned, it can absolutely, as a standard function, allow you to adjust your spindle, override while in thread. You can do degressive or linear cuts. Degressive, it's going to reduce the cut per pass as I get deeper in. OD or ID, and then you just fill out the dimensions of thread. So what's the OD? Where does it start? Where does it end? How much advance do I want to give it? So, usually I'll use about 1 thread rev. So like on an 8-pitch thread, that would, I might want to give it just about 1 thread pitch for its start. So it means it's going to start 100th thou away from the part. LR, do I want to do a chamfer leading out? If I set it to 0, it's going to cut as much of the thread as it can and then wrap it to clear the back of the thread. What's the thread height? What's my in-feed angle? And this AP can be toggled between an angle or a value. I like to set it as an angle, and right now I'm using a 30-degree in-feed angle. First cut depth. How much material am I leaving for finish pass? Number of spring cuts. I want to back off VR, so my pull off, I usually like this to be a little higher than my thread height. It's not really all that critical, so it's because the value off the major. Am I doing multi-lead threads? Yes or no, and how many leads? And then do I want to control my starting angle of my thread? So if I needed to time the thread in relation to something, I could. I fill out the event, it stores it. In this case, I'm going to maybe go in and drill the hole, so I can jump over to drilling. Now, if your machine does not support milling tools or live tools, the only button you're going to get is drilling centric, because that means I'm drilling basically always in the center of the part. If you have live tooling, and we'll go into live tooling in a later seminar in our series, then you'll get to start to leverage some of these live tool functionality. So in this case, we're just going to do a simple drilling centric. You can do drilling or tapping within this drilling centric. It automatically supports chip breaker, chip removing cycles, but if you don't want a peck drill, you just create it where your depth and your peck are the same value, and you're drilling it. You fill out the page, you hit accept. Now we have the drilling cycle. Now in the drilling cycle, we do have the ability of compensating for the tip or the shank of the tool. So like in this case, I told it go 225, 2-inch 225, 2¼ sorry. It'll go that plus whatever the projection of the drill is, because when you create a drill, You also tell it the tip angle. Okay. Then my final function is going to be a part-off function. So I'm then going to go back to turning, select the cutoff option, and then filling out this page. So in this case, I'm going to select my plunge cutter. And when you're creating grooving tools, you'll not only tell it your standard information like your corner break, because we can profile and finish with the cutter. You're going to give it the insert width and then a rough length of the overall insert length. The insert length's not that critical. It's the width that's obviously critical because the system's going to automatically compensate for the backside of that tool. You don't have to do it. It'll figure it out for you. But you got to give it the appropriate width right here. From there, give it some feed rate, some spindle speed. The maximum RPM I'm allowing the physical spindle to go, because in this case I happen to be running constant service feed for part off. Where am I? What's the OD and what's the total length of the part? It'll automatically add the insert width to this value because it knows that this is a part off part. I can plug in a chamfer or radius. FS represents chamfer. And then if that was an R, that would be a radius. So I was doing a 50 thou chamfer at the back of my part. This is kind of nice. This is our reduced speed and feed for our part off. So, you know, we've all been in that scenario where I'm flying down the part and it pops and it's going real fast and flies across my shop or misses my parts catcher. So what this is saying, at what diametric location do you want to now slow down the spindle and slow down the feed rate? So here I'm getting to be to an 1/8 inch diameter. I'm then telling it I want to reduce my feed rate. I want to reduce my spindle to a straight RPM at a given RPM. And then where do I want to end at the very end of the cutoff cycle? So you fill out the page, you hit accept. Cutoff cycle's here. So now we have a programmed part. So I do a final simulation, and you would just keep adding, obviously, operations as you go on your specific jobs. But the mechanism is really what you want to kind of gain from here. So we rough it out, we finish it, tool comes in, threads it, then you guys see the drill, come and drill it, and we part it off. If I'd like to see the internal, see that drill, I can go to further views and select half cut view, and that'll give us a sectional view. You can have this up, so you know I could have had that while I was machining the entire part, and then I could see the cutter come in. You can control the speed at which it simulates by going to Program Control and either using the overrides up or down, or just hitting 100%. It's nice because you can really gain a lot of control when you're simulating. So, you know, if I slow it way down, I can really start to see what's happening. You know, here I can go 5% feed. You can, you know, cycle stop. You can reset. You can do a whole bunch of things. Now, this is all independent of the machine running in auto. You can do all of this functionality while it's cutting another part. So you can concurrently program, concurrently simulate all this stuff while it's doing another task. Okay. So from here, back in our presentation, the last section I'd like to talk about, we'll just take a look at it pretty quickly because we are getting a little late on time, is our auto mode. So auto mode is the area I would physically go to run a part program. So some of the things we'll talk about is we'll talk about our basic blocks field, our distance to go field, bringing up simulation in auto mode so you can use the same simulation, but that's a concurrent simulation to wherever you are. Maybe starting in the middle of a program. How would I start at some point in the program? So when we look at auto mode, first thing is how do I get into auto? Well, one of two ways to get into auto. I can access auto right now by hitting the execute button in the lower right-hand corner, or back in my program manager, I could hit the execute button in the upper right. Both functions will do the same thing, and what they'll do is they're going to put me into auto. There I see I'm in auto. I left my spindle running the whole time. Put me into auto and loaded the tool. See, sample one's, or loaded the program into memory. Sample one's already here, it's active. I didn't have to do that as a separate step. It's all automatic by just saying, hey, I'm in this program, or I'm highlighting this program, and I tell it I want to execute it. If I had just hit the radio button for auto, then it would have gone into auto with whatever the last program, or if there was no last program, just a blank auto area. So I do have to physically either go into the program or use execute from program manager to get in. Now you do want to be aware of where the highlight is, because this is one way to start in the middle of the program. So while I left my highlight on cutoff when I went into execute, it automatically stages and tells me that block search mode has been activated. So if that was a mistake, because I really just want to start from the beginning, just simply hit the reset key and it'll rewind the program. If you really want to start from there, certainly I could have hit cycle start and it would have started. If I'm starting from the beginning, it's as simple as right now initiating cycle start. It would start machining my part. I can certainly control with my overrides how fast it goes. Now let's say I want to see kind of all the results of these different cycles. Well, if you hit basic blocks, it brings up all of the resulting lines. So a lot of people, they get concerned when they see conversational type of programs because they don't get a good idea of where the machine's going to next because the cycle figured it out. Just hit your basic blocks and it'll bring it up. You have a timer parts counter, so it'll give you cycle time, time remaining. You can do work piece count if you want to. In this way, it'll track your different work pieces, where you are within a production run, that kind of stuff. You can control the system in the program control. So program control allows me to maybe enable optional stops. PRT is like an axis lock mode. So the system will run, but the servos won't really move. Dry run, I want to run it. I don't even have a part in there. I just want to run it in the air real fast. I can initiate a dry run mode. RG0, reduce rapid traverse. So let's say I got a new machine or a really fast machine and I'm proving it apart and the rapids are just too quick. I can select that. You'll see the little RG0 whenever any of these are active, because the panel may not always be up, but that doesn't mean they're not active. So right now I know dry run is on because I see DRY, and I know the rapid reduction's on. So if I come back into it, I can toggle them on or off. Single blocks, by single block modes, we have a couple different modes. The two most popular are rough and fine. So single block fine is what we're all kind of used to. That means every time I'm going to do or execute some kind of move or command, I got to hit single block. Single block rough will allow non-motion commands to pass through, will allow can cycles to kind of go through. So like if I'm in the middle of a peck drilling cycle, it'll allow the peck drilling cycle to complete, but not move to the next location, let's say, until I hit cycle start again. So that gets kind of handy. So there's a bunch of different ways for me to control how the machine's going to react. If I want the simultaneous record on, I pick up simultaneous record. That's going to bring the graphics. Now when I initiate cycle start, I'll physically see the cutter, and it's a real time. Certainly simulation runs a little quicker, or shall I say the SINUTrain mode runs a little bit quicker than it normally would in the real world, but you can see that this functionality would allow you to start to see what's happening on the machine at the same time as running it. Okay, so we covered a lot of material in certainly a short time. I appreciate everybody hanging on there. I want to now open things up to our Q&A panel. So we do have the chat window, but sometimes it's easier if you guys use the Q&A panel for me too. So any new questions that you guys are going to pose, if you go up to the little pull-down toolbar and see Q&A, just click on it, type the question in, and then we can start to talk about some of this stuff. So with that being said, let's open up the floor to any questions. So we have our first question in. Is it possible to convert a ShopTurn program to a G-code program or vice versa? No, it is not. So ShopTurn programs will only solely be ShopTurn programs. You can certainly bring up basic blocks like I showed you to see those resulting codes. But in our scenario, when we built ShopTurn, we built it at the same time really as building the program guide in this interface. So it wasn't like an add-on piece of software where we had to translate it out, because in the back end we're really still kind of running G-code, and this is just a way for us to kind of build a G-code file. So with that, we've never created the mechanism to be able to take a conversational file and port it to just a simple native G-code. At the end of the day, in the back end, it's really running these cycles. So it's not like we're translating in the back end. So no, you can't port it out to G-code. Now, when you get to our G-code section, what you do have the ability is standard in our G-code. So if I had written a G-code program, oops, sorry about that. Let me type in a name here. I'll just give it some simple name. We automatically have conversational support in G-code. Program Guide comes standard and has had this functionality for probably 20 years. So when I'm writing a G-code file, I fill out the page conversationally. I see the cycle. So in the control, I can always open up any cycle, whether it's created from a CAM system or it was physically written at the control. I can open it up conversationally. A lot of guys, you know, a lot of builders try to leverage what we would call cycle support as conversational programming, and it really is not. True conversational is true conversational. The entire length of the program could have been conversational. Cycle support is a standard feature in our control, and it's right in Program Guide. So you get that for all of your CAN cycles. Hopefully that answered your question. So we got a few more questions came in here. Let me just expand my panel a little bit. Norman Blyer is joining us. Hello, Norman. Before I end, can I comment on what Siemens is showing at IMTS, especially what might be new? Absolutely. So those of you that may not be aware, the IMTS show out in Chicago is going to be happening in a couple weeks, actually 2 weeks, so it's kind of scramble time. We're going to have 4 machine tools in our booth. We're going to have a new 828 that supports 2 channels with a sub spindle, so that's definitely new. We have more demos and new added features on the My Robot functionality. One of the big things we've been doing as of late is handling robotic part loading right inside the control. So instead of having to have a separate robotic control with its own programs to handling your work loading and unloading or your part loading, we can do that as a separate channel right internally in our control. So all your part programs for loading and unloading can be right next to your part programs for actually making the parts. So that's some of the new stuff, as well as a whole host of other different things that we're going to have there. Michael has a question here. Seem to have trouble toggling between incremental and absolute, but once I input my coordinate value, I had to delete my numbers. Well, sometimes what can happen, Michael, is especially if there was mathematic calculation applied, that one number I input may be then affecting other values. So then by trying to change it back, it doesn't want you to do that, primarily because it is there was math applied to that field. So kind of what we're talking about here is if we go into our sample, we go into our contour, and you know I'm in some shape, and I say, okay, I want to now make this an incremental value. It says it rejects it. I have a feeling that this is probably what you were seeing. Well, that's because that number was highly dependent on all these numbers being calculated. So in that scenario, yes, I would want to delete the number, and then I can flip it to incremental and put in a correct number. Steve, what does the various key function do? So the various button on our keyboard right next to our increments allows me to create like a variable. So not various, but variable for my increment or job. So when I'm out in machine, right, and I'm in job, if I want to, you know, if I'm moving some defined location, I can jog the machine based on a value, right? So here I have it a tenth for 1, 100 is going to be 100 or 10 thou, and I can go right up. Well, variable is going to be under settings, so I'm expanding my soft keys over. On the machine tool, you would do this with the right arrow button, generally next to the menu select key. I access settings, and I can now go in and I have an option for variable. So we could create. Now there is PLC logic involved with this, so not all builders support it. Let me see if the simulator does. So I can put a value here, and now it should allow me to, yeah, it doesn't look like I have the PLC logic. It should allow me to then, jog it that variable value. So that's where it kind of comes in. Okay. Is it better to always run a program from the NC memory, or is it not important? Run from a local drive. Are there any recommendations regarding the use of a different memory for CN and local drive? That's a great question. As far as running programs, in our system, you can certainly run from any source. And generally, the only limitation on large files is sometimes the buffer, when you're viewing the program in our auto mode, it might not show you quite as much of the program. But that is something that we've made great strides with Operate to be able to support. Some of the older systems and the pre-Operate systems, you lost some functionality. So the core program would always run, but maybe we couldn't edit, or if we did allow editing, simulation wouldn't work. Now we've really opened up a lot of those restrictions. So pretty much we could care less where the program resides. With that though, when using a USB, I always warn people to not make that a normal practice, and two primary reasons. One, it's not a very secure connection. Certainly anybody can come in and pop the thing right out while it was in the middle of running, or just in jiggling, it's not a great connection. But even probably more than that, there's a lot of garbage USB sticks on the market. So, hey, I got this free when I opened my bank account, and that's what I'm trying to run my $100,000 machine tool with. So with that said, use it. If you get in a bind and you want to run something from the USB, absolutely, but don't make it a normal process. We have, from Robert. How you doing, Robert? What is sync thread? Is it thread repair? Absolutely. Sync thread is our thread repair function. So the old systems, pre-Operate, you used to have to go into the CAN cycle, and that was where we had the mechanism for you to actually align your spindle to your tool, because that's really what you're doing when you're doing a thread repair. Now we add it as a function, and the function is within jog. So I expand my soft keys over, and I see the sync thread function. So in sync thread, I come in, I tell it that yes, I want to sync to my primary spindle. Certainly I could have multiple spindle sports if I had main spindle, sub spindle. And then you would physically move the tool over, just like you see in the image, and engage the thread into one of the leads of the thread. Once you're there, all you have to do is simply hit teach spindle, and it will now orient the spindle to that tool. From here, I can immediately go back in, like, let's say the part program I was running, and now the tool's timed. So even if I was in the middle of a production run, I pulled the part out, gauged it, it was no good, I just come back in, do this function, and run. Now, you certainly have to make sure the part is still in its original Z location. So I'd either set a new Z tool length offset, or maybe bump stop the part or something. And this is what times the spindle to that physical tool. Great question, Bob. Okay. Well, that was great. We got a lot of questions here. Just looking over just to see. Looks like I got everybody. Hopefully I did. All right. Oh, Danny put one thing for Norman. Another thing that we will be talking about a little bit at the show is additive machining practices. And we are going to have, I don't know if we have one in the booth or not. Forgive me. I don't remember if the DMG machine in the booth is going to be showing additive machining. I know DMG will have additive machining in their booth running from our control. Additive machining is something we've been doing quite a bit with some of the high-end builders. Okay, so if that's pretty good, I think we're right on the minute here for an hour and a half. Looks like we needed all of it. Thanks, everybody, for attending. I will certainly send out an email. Everybody should receive a thank you email for attending with the link to the recordings. Again, I will send out invitations for the next one, so hopefully everybody's found this helpful, and we can continue this in the future. Great. I'm going to end our recording here, and we'll